This is running at 300 FPS. Watch what happens when I turn on one thing. That's 4x drop from one camera. And I built this on purpose, so I could show you exactly how to find a problem like this yourself, using a tool most people ignore until something breaks. The Frame Debugger. Let's find out what's actually happening. So what is the Frame Debugger? Frame Debugger simply lets you through a single frame, but it lets you through draw call by draw call. So each one of these things that you see here is a draw call. And see exactly what the GPU did to build this final frame that is being rendered on the game view. This is a very powerful tool that will help you solve GPU bottlenecks. Welcome to 100 Tips in Unity. This is episode 15. So before you even open the Frame Debugger, there is a single step that you all need to do. That is profiling. Profiling is so important. Let's close this. Control 7 to open the profiler, get used to that shortcut. And let's check if this project actually needs frame debugging in the first place. Make sure record is on, hit play, and play the game. Now I also have an FPS counter that I've made here. And it's running at almost close to 300 FPS. And you can see that right now, there's no need for it. Okay, occasional spikes like these will happen. That's because we're running the game in the editor. Everything is looking good. But I'm going to pause the game now. And then I'm going to enable my minimap camera and my minimap canvas image. Okay, I'm just going to enable them. And now if I play the game again, you can see it is around 70 FPS. I have a minimap here. I'm going to pause the game. So everything is running slower. 70 FPS is a big jump. So let's analyze what the problem is here. You typically don't realize that this is a GPU problem. So that's why we are profiling first, to check what the problem is. And the first place to look into is the highlights. So I'm going to go to this frame and then click on the highlights module, and it's going to show me the data here. You can see once I enabled my minimap, the CPU and the GPU started taking more time. So does that mean that this is a CPU problem and not a GPU problem? Well, we can't figure it out. We need to investigate. And here on the right, it shows you top markers in this frame. And you can see the slowest marker is a wait for GPU marker. And it shows the time the CPU spends waiting for the GPU to finish rendering. So this is the part that is actually taking the lag. So you can see that this is actually a GPU bound issue. Okay, so let's open the Frame Debugger. We go to Window, Analysis, Frame Debugger. Here you have the option to connect it to the editor or to the build of a game. Or you can connect it to an IP address. I recommend connecting to the build. Editor is fast iteration, but you should ideally do profiling in the build version of the game. You would already have a build to connect to with the Frame Debugger as well. How do we do it? We simply click on Enable. And that is going to run a single frame, okay? These things will bug out. Don't worry about it. I don't know why Unity likes to do it, but this thing will pause the game. Essentially, all of the draw calls that are required for your camera to render the scene will be shown here. Okay, so there are a couple of things that you need to learn. All of these numbers that you see here are draw calls. Okay, you have URP.render single camera, a main camera. So the main camera has a 40 draw calls associated with it. A draw call is the CPU telling the GPU that you have to render this mesh with this material in this particular way. Okay, so this number could be high, and you solve those using a concept called batching. I have an entire video on batching for the built-in render pipeline. URP has something called the SRP batcher that does it automatically. If you want to learn more about batching and draw calls, that video is a much better one to look into. Another thing that you need to learn is about render textures. In Unity, by default, everything is rendered into a render texture. If you click on this thing, execute render graph, everything is rendered into a render texture called game view render texture. Okay, it takes the size of the current game dimensions, which is 1011 by 512. For an actual game, this is going to be 1920 by 1080 or your resolution of the monitor. And it contains a lot of render textures. Everything is rendered into a texture. Okay, you can see that the shadow maps are rendered into the texture called this one. The normal passes is rendered into this particular texture. Draw opaque objects, draw skybox, everything is set into a texture. Okay, as you can see here, a render target is just any GPU allocated surface a draw call writes pixels into. And Unity has an RT handle API, which is essentially like a wrapper around a render texture. And it uses things like pooling and aliasing on top of it to make things optimized. So anything Unity lists under this render target field is a render texture by definition, even though this thing says it's text 2D here. They're all essentially render textures. And some of them are drawn on top of one another. But every time the CPU tells the GPU to do this thing, it takes a draw call. Okay? And that is what this list comprises of. Draw calls and how things are rendered into a render texture. You get full details here. Now, what should you look for in this particular list? How do we find the issue in our case? There are three things that you need to look into. First thing is the draw call count. Is it way higher than the object count in your scene? Let's say you have 200 objects and then you have like 200 or 400 draw calls. That is something that you need to look into. Okay? You need to make sure that things are batched properly. The second thing to look into is, are there repeated render textures? So for example, here we draw all of the rendered opaque objects into this particular render texture, and then we draw the skybox on top of it on the same render texture. You can see it's the same render texture. So both of these processes are rendering to the same render texture, which is okay in the case of opaque and skybox. It's by default. But if it is happening on your custom objects that you've added, then it might be something. You also need to look into if batching breaks. Okay, there are conditions for batching to not work. I've explained it in detail on the other video. You can check it out. Okay, so the whole point of this is observation. Okay, but let's solve the problems in this particular project. So you can see there are two cameras, main camera and a mini-map camera. 40 draw calls and 18 draw calls. By themselves, they don't look harmful. 40 and 18 are not huge numbers to work with. So what exactly is the problem? We already know the main camera is not the issue because everything was working well before that. So we know the issue is with this mini-map camera. You can see it is executing into a render graph. It is rendered into a minimap RT. And you have a bunch of different draw calls here. Opaque objects, skybox, shadow maps, normal, pre-pass, a lot of different things. Draw transparent objects. Really cool. So by themselves, you don't see a big thing here. So what exactly is the problem? The problem is, it's a very obvious one. If you go to the first one, you can see that the size of the minimap is 4096 by 4096. It's using a decent profile, but the size is very high. And a similar size is being used for all of these passes. So that could be an issue. Also, if you look at it, there are shadow maps being rendered. Do we need shadows in a minimap? Probably not. So we can disable those things. Transparent objects are being rendered. We might not need it. So we could avoid these three draw calls. Skybox. There's no need for a skybox for a minimap. If you go in depth, you might realize some issues. You'll see the draw calls here. If you go down, you can also see properties related to this. Things like meshes and everything will make sense. What shaders are being used and everything. And you can see they are all batched as well. So it's a combined mesh that is being rendered. And then you have a cube and then you have a plane that is being rendered. So by itself, it's not bad, but the only problem was the size. So let's go to the render texture that is actually being rendered here. And you can see the size is 4096 by 4096. But the actual mini map in the game is only 150 pixels by 150 pixels. So let's change this to the actual size that we actually need, 150 by 150. But then there's also things that you can optimize on the camera. For example, the mini-map camera. Here, you can go down and you can disable shadows for this particular camera. You can disable post-processing and stuff. I'm going to disable occlusion culling because we don't need that. I'm going to change from background type from skybox to uninitialized. And by itself, it's going to be great. Maybe I'll change this to an orthographic camera or something. And right now we have optimized a lot of draw calls. You can see it's still very good enough. And you can see the number of draw calls have reduced by this much. And if you go to the output, you can see That's just 150 by 150 size. And you can learn about all of the textures. Maybe the texture size is too high. Maybe you want to use a different compression. All those details, you'll find it here. Okay. So the whole point is to click on stuff, read through stuff, and then figure out what is actually the trigger. In our case, it is enabling and disabling the minimap, and then reading it. Okay, that's how it is. Just check out the numbers, see if it is high, and learn. Just another handy tip: if you want all of this information, you can right click and copy all details, and then you can paste it somewhere here if you want it in a return format. Then that is all for the frame debugger. Just have fun with this. That's the most important thing. So that is all for this video. I hope this was useful. Let me know if there are any doubts regarding frame debugger. These are all just the basics that you need to learn. And just knowing this will improve your levels. Take care. I'll see you in the next one.